the keynote on the art of simplicity. It's a great pleasure for me to be here in front of you to talk to people that I enjoy the most, the programmers in the world. I travel a lot for speaking in conferences, teaching courses, working with clients. On one of the recent flights, I had somebody I was sitting next to, and he asked me what I do for a living. I said, I'm a programmer. He said, that's the easiest job on earth. I said, well, that's great to know, but can you tell me why? He said, because all you have to know is zeros and ones. And I told him, yeah, that's pretty good, but do you know why they pay us the big bucks they pay us? He said, why? I said, because we only know how to put them in the right order. Well, the point is, we work with complexity every single day. We try to make things work, and it's not easy. It takes a lot of effort for us to comprehend the problem given to us, to understand requirements, and to be able to deliver the software that we have to deliver. And when we deal with complexity, there are several things that make it really hard on us. But I'm going to say, in this room we have probably one of the most complex, if you will, or more capable, I would say, that you can ever imagine. And that is the human brain. And the human brain is probably one of the most complex and the most capable we can ever think of. We are really phenomenal in coming up with solutions. But unfortunately, one of the things that affect us a lot is our emotions as well. It clouds us. We're not able to think clearly. And we complicate things. And then hopefully, eventually, we can figure out things and we make things simpler. One of the conversations in my house often lingers around Schrodinger's cat. My children often like to talk about Schrodinger's cat. And we talk about how Schrodinger thought about this mental experiment, thought experiment. And he said that there's a cat in a box. We can see through it. Here can see what's inside. There's a vial in it. And he said that at any given time, the cat is probably dead and alive. Well, we can do a lot of these kinds of thought experiments. We can try to understand complexities and the problems we solve. But Confucius said, life is really simple, but we insist on making it complicated. So we really struggle to really make things simple. But I wanted to ask the question, first of all, why? Why do we want to make things really complex? And I think I have an answer for it. And the answer really is, in all honesty, it feels good to make things complex. Come on, let's be honest about it. You create something, you go to your colleague, you show what you have done. Your colleague looks at it and says, yeah, that's simple. You feel let down. You say, I'll be back tomorrow. I'll come back with more complexity. So it feels good to make things complex. There is another reason why we make things complex. People think that we are smart and useful if we make things complex. If we make things simple, maybe we don't really get the recognition we need. The third thing, a real important reason to make things complex, is it's the best way to get job security. Because when it comes time to lay off, they'll say, whatever you do, don't touch Joe. Nobody understands what he's doing. So it gives us job security when we create complex things. But unfortunately, though, that's not the smartest way to live. As Einstein said, any intelligent fool can create something complex and violent. But it takes a touch of a genius and courage, and I want to underline the word courage, to make things really simple. And I think it's extremely important to keep that word courage because we feel really intimidated when we try to make things simple. We get frowned upon, we get laughed at, and we are told, come on, that's too simple. We really can't really possibly be giving the solution. So it really takes courage to really bring up something that's really simple and provide, and that is something we have to work towards. But the problem really with simplicity is almost everyone you talk to would agree to you and say, we got to make things simple. The problem is not that we don't agree that we want to make things simple. The problem is we don't know what simple is. If simple is sitting next to us on a flight or a train, would you even recognize what simple is? So while a lot of us can agree on that we should make things simple, very few of us really know what simple is. And almost none of us know what simple is in every given context. So it's something that's very subjective. So I want to say, how do we make things simple? It turns out that's not really easy. So I'm going to talk about instead what is not simple. So maybe if we can understand what's not simple, maybe we can identify and avoid it when it comes to time to avoid and create things that's simple. So I want to say the very first thing, that simple is not clever. Now, we all do this. We develop software for a living. And there's a pride in what we do. We want to make things really clever. But why do we make things clever? When you make things clever, it feels really good. That proverbial hand comes and pats you in the back and says, you are awesome. And it feels good to really create something clever. I remember the other day, a few years ago, I was writing something. I got an email from a client saying, something is wrong, we got to fix this. I looked at the problem. It would have taken me 10 minutes to fix it. Oh no, that cannot be done that easily. So I said to myself, I don't want to fix this problem. I want to fix the mother of all problems. So I spent an hour on this problem. And when I fixed it, I had an out-of-body experience. Venkat literally got up, went around and hugged me in the back and said, you are awesome. It felt good to have created a solution for not the problem given, but every meta problem that could come across. A few weeks went by, I got an email from the client saying something absolutely disastrous has happened in production. I looked at the email, replied to them saying, I know what it is, I'll fix it. And they said, oh, we know you're smart, we know you can fix it. I said, no, I can fix it not because I'm smart. I can fix it because I caused it. That wonderful, clever solution I created backfired and failed in ways that I never imagined. So what did I do? I rolled back the change I had made, put in the place the 10-minute change I had to put in. It's been about 5 years, no questions asked. So I learned a very important lesson that day. Today, when I sit down and write code, the minute I finish writing that piece of code, if my mind tells me, oh, that's a clever solution, I immediately delete it. I don't want clever solutions, I want clear solutions. That's very important. Well, take a look at this code for a minute. We all know what this is. This is class enum, and then E extends enum E. Oh, that noise you just heard? That's your brain throwing an exception. Well, the point really is, this is a very clever solution. I'm sure this has meaning, but not something very easy to comprehend at all. And it becomes really hard. When I work with clients often, they come to me and ask me the question, how do we obfuscate our code? And I often ask them, well, why bother? Your programmers write self-obfuscated code already. They themselves cannot figure out what they are writing after a few weeks. So we really write very clever code, and it becomes really hard to understand over time. And I came across this piece of code. And if you look at this code, it's got a float x coming as an argument. Well, that's great news. I don't know what x is, but I got half of that right now. And then, of course, it does this wonderful operation. And then you have this, and then you have that operation. But I don't understand most of it, but here's some good news. Whatever x was, we are returning x finally. Well, when you look at a code like this, how do you comprehend what in the world code like this is doing? And when you have to maintain this code, when the boss is around you asking, are you done yet? How do you maintain a code like this? It becomes incredibly difficult. And you know how people told us, when you write object-oriented code, we represent the real world? I don't believe that a bit. But this developer believed it and took it to the next level. He was writing a flight simulator. And so he created this. And this is incredibly difficult to work with. My problem is not that this developer wrote this. My problem is, what did people around him do? Somebody should have said, dude, don't do this. And the point really is, when we create code that's extremely hard to maintain, how do we really maintain with it? These are all examples of cleverness. Well, I said the simplicity is not something that's clever. Simple is not necessarily familiar. And I want to emphasize this because a lot of times we confuse the word simple with the word familiar. And these two things are not the same at all. Familiar is something you have seen several times over. Simple is actually easy to work with. And those two are not necessarily the same. Sometimes what's familiar becomes easier to work with, but that doesn't really make it simple by any stretch of imagination. I'll talk about this a little bit further, but it's a human tendency to reject what we are not familiar as maybe something that's complex. But we don't deserve to really evaluate whether it's simple or complex until the time when we really begin to understand and become familiar with it. So let's talk about that with a little example. What is this? And generally, I would probably have somebody in the audience say, it's simple. Well, I didn't think it's simple, but that's because I'm not familiar with it. So I found out what the meaning was. It was actually simple, uncomplicated, casual, and common. But clearly, it's not for any of us who don't understand the language. And that is one of the important things to understand is that what we are not familiar with tends to become complex in our minds, but that's not really fair. Let's talk about a fairly simple problem for a minute. So here I have a list of names given to me, and what I want to do is a very simple problem. Print the name only of length 4, in uppercase, comma separated. Come on, that's a very simple problem, isn't it? That's a basic programming problem. For string over here, and we'll say name, comes from names, of course, and I want to output the name given to me. Oh, but wait a minute, it should be in uppercase. No worries, to uppercase. I can do that easily. But it says only names which are of length 4. So if name.length is equal to 4, then I want to print it. But I want them comma separated. Not a problem, I can put them as comma separated. But wait a minute, I want them on the same line. No doubt about it, I can do that easily. But when you're done, you realize something. There's a stupid comma in the end. Have you ever seen this problem before? I know everyone has gone through this at least once, isn't it? Remember the day you came across this problem. You said to yourself, this is not happening. Are you serious about this? And then you sit and scratch your head for a minute. How do I get rid of that stupid comma from the end? This is almost done, but that almost is what kills us. How do I get that comma removed? I could put this into a string and remove it. Damn it, string is immutable. I could put it into a string buffer and build it, but now we have to use string builder. By the time you get through this, you're not too happy about it. Then you would say, wait, that actually is a simple problem, simple solution for this, isn't it? What I could do instead of doing this is I could say for int I equal to 0, I less than. Is it less than or equal to? I'm not sure anymore. But anyway, names dot, is it size or length or count? If it's an array, it's a length. If it's an array list, it's a size. This is an array list, okay, it's a size. But it's still less than or equal to, I don't know yet. And then I plus plus. And then what am I going to do? I'm going to say if names dot get of I, this is adding insult to injury, isn't it? And then length is equal to 4. And then what you're going to do, output, but in this case, of course, I want to just output that without println. I'll put the names dot get, and then I dot to uppercase, great. But is that going to fix the problem? No, I still need the comma, but where do I put the comma? If I is not equal to, you know where this is going, right? And then you come to this point and say, damn, that doesn't work either. This is an example of accidental complexity. A very simple problem, but not a simple solution. And by the time you're done with it, you're in complete disbelief that something as trivial as a problem that was given to us takes such an amount of coding for us. And that is a familiar solution. For loop, obviously, is something we're all very familiar with, but it's not a simple solution at all. Now, why is that solution not simple? The very first reason the solution is not simple is, look at that one line. I'm going to say that's a very complex for loop. People will argue that's a simple for loop. No, that's a familiar for loop, not a simple for loop. It has way too many moving parts in it. You have to initialize I properly first. You got to set the boundary conditions properly. You have to increment it. Then you got to extract the value. And yet it's still not done because you don't know what the last element is. And this is incredibly difficult to do in the traditional for loop. And that's one of the reasons why this is what I call as accidental complexity. It is really complex to do this job, and we tend to really suffer through it. But thankfully, maybe an unfamiliar solution that could be really simple as well. Let's give it a try again. For example, what I could do here is I could say output, what a relief, we can start with the end in the mind. We could say names.stream. I really want only values of names where the name.length is equal to 4. I want uppercase of the names, so we could say string over here, and we could say to uppercase, and we got the uppercase values. But then I could do a collect, and this comes from the collectors, of course. And then I can ask it to do a join, so we could say joining using comma, and we could say that give these to me comma separated. So we can say, given a collection of names, give me only the names that are of length 4, transform them to uppercase, but collect them joining the comma and get me the result. The day that I learned about joining, I cried that night. I'm like, gosh, this is how it should be. Absolutely, this is how solutions should be. Not complexity you have to deal with every single day, but something that's obvious, something that's trivial to get the work done. And this is an example of something that's very unfamiliar to most of us, but largely, of course, as you can see here, is extremely simple in terms of the solution it provides. And that is exactly the point we really want to get to, is that it's very unfamiliar until we get used to it, but it's simpler in the long run. Well, something that's unfamiliar might actually be complex, sure enough, but we don't even have a way to judge it until we get to the point where we can find out if it is really simple or complex when we are unfamiliar with it. So don't confuse familiar with simple. It's important to really take the time to get familiarized with it before we can evaluate that for simplicity versus complexity. Well, a lot of us are familiar with the imperative style of programming, but declarative style of programming is a lot simpler because it gets to the point directly. It conveys the main idea very easily. Well, simple has fewer moving parts in it. And when we have a lot of moving parts in our code, it becomes enormously hard to deal with it. That's where the accidental complexity comes in the code. We want to really minimize this as much as we can. So the next thing I want to talk about is simple is not over-engineered. This is another thing we tend to do. We add a little bit of clutter in the code as we work on it. This guy made his name by designing complex ideas. Rube Goldberg machines were comical solutions to problems that were really complex, and there is no reason for complexity to be this way. My children often spend time in their schools building Rube Goldberg machines as a way of just having fun, building something enormously complex to solve a very simple problem. And when we do this, I'm sure every one of us has written something like this in code at one time or the other. I remember one day at work, I was looking at a piece of code. And what this developer had done was, here is the data in a database, in a table, in a row, and this code is taking that one piece of data and a 250 lines of code to transform that into XML. And then he calls this other function and passes this XML. I took the time to read it. I got it. I know what's happening now. Then I look at the second piece of code. It takes this XML, parses the data, and gets it back, does a little operation with it, and puts it back into the same database. And I was scratching my head. I went to the developer and said, I'm looking at this code. It's taking the data, transforming to XML, and then converting XML to data again. He said, isn't that cool? I said, no, it's not cool. He said, no, you need to have a vision. I said, what kind of vision am I lacking here? He said, look at it. Yes, I am looking at it. Well, the data can come from anywhere now, and the data can go anywhere in the future. I said, given the requirements we know, where does the data come from? That place right there. And where does it go? Right here. Then why are we interested in from anywhere to anywhere? He said, no, Venkat, you need to have a vision. While he was saying this, I took my phone and was fiddling with it. He said, hang on a second. He said, hello? I said, hello. Hey, is that you, Venkat? I said, yes. Why are you calling me on the phone while you're in front of me? I said, you need to have a vision. I could be anywhere in the world talking to you now. Why should I talk to you in person directly? Well, we tend to really complicate things unnecessarily. We feel this clutter is needed. We got to put this clutter around everything we do. Well, let's first solve the problem at hand. Let's get things working. Let's improve on it later when we know better. Let's not create these Rube Goldberg machines. The next thing I want to emphasize is, I said simple is not clever, simple is not over-engineered, simple is not necessarily familiar, but simple is not also terse. I want to distinguish between the word concise and the word terse. Sometimes we feel we got to make the code really short. That's not a good thing. I want the code to be short and concise not short and terse. So given this, I came across this code honestly on a project. I was working with a client as they were looking at the code, dealing with stuff, and the developer flipped to the screen, showed me a piece of code, and then he moved on. I said, whoa, go back to the code. He said, okay, all right, and he went back. I said, do you mind if I take a photo of this? He was very kind to say, all right, go ahead. And I took a photo of this. And so here is the code I saw. Here's the photo of the code I saw. You may look at this and say, what's really big deal about this? Oh, sorry, I didn't want to show you this. What I really wanted to show you was the line below this. It literally said, God help me, I have no idea what this means. This is an example of this particular code is from a system. A single license to this product is $1 million, by the way. And developers come to work every single day to maintain this, and they have no clue what L1, L2, L3, and then to add insult, P1, P2, and P3 really means. And when you deal with these things, this is an example of terse and not concise. The goal is not to keep things very short. The goal is first to keep things clear, and then maybe short after that if needed. So given this example here is a unit test I've written where I have a max profit, which I want to make sure is throwing an exception. We know these things are called exception tests. Well, given this exception test, we can say, well, that looks like a lot of code. I want to make this shorter. Well, here is a short piece of code. And this is from JUnit 4, as we know. And in this example, as you can see, it says expected equals rot cutter exception.class. And I don't use this in JUnit 4. In fact, in my coding practice, this is not allowed. And the reason I don't like this is an example of a code that is terse and not concise. There is quite a bit of possibility where this code may actually give us a wrong result, meaning the test may pass for a wrong reason when it shouldn't be passing. A better way to write this is to make this verbose like it is right now, or if you really want to make it concise, you could try something like this. Oh, by the way, this is supported in JUnit 5, something like this, not exact syntax, but something like this is supported in JUnit 5. Well, where does this idea come from? Well, remember, .NET had attributes even before Java introduced annotations. And so in .NET, NUnit, which is the equivalent of JUnit on the other side, NUnit had a similar syntax for writing exception tests. But the NUnit guys are really smart. They introduced this idea, and they waited long enough for the Java folks to pick this up. And the minute JUnit implemented it, NUnit deprecated and said, this sucks, don't do it. So now NUnit is stuck with it. Well, JUnit is stuck with it. NUnit has moved on. And they decided to deprecate it for the reasons I mentioned earlier, I think this is really a poor way of writing it. There's quite possibility that a test may pass for wrong reasons. Well, thankfully, NUnit 5 is introducing a better way, and JUnit 5 rather, is introducing a better way where you can use lambdas to write tests. And in this case, of course, you can specify that you can give this idea to the code and say, tell me this code is going to throw this exception and be able to deal with it. So don't confuse terse with concise and simple. Our goal is not to make things short and terse. It should be short and concise, not short and terse. That is something to work towards. One of my favorite quotes is by Tony Hoare. It says, there are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies, and the other way is to make it so complicated that there are no obvious deficiencies. I remember one day at work, a client of mine, I was looking at a piece of code and I found out there was really a disastrous multi-threading bug in the code. When I noticed it, I was like in panic. I said, my gosh, look at this. This variable is totally unprotected. To the developers, I said, do you realize this variable is being updated by multiple threads, but it's totally not protected? And the minute I said it, one of the developers got very angry and said, hey, Venkat, this application has been in production for 3 years. What makes you think you can come and scare us? Before I could answer, and thankfully I didn't have to answer that question, before I could answer, one of the other developers said, but remember every 3 weeks the program crashes and we don't know why? And this is the example where we don't even have a clue why things don't work and where the bugs could potentially be hidden. That becomes really hard. Well, I gave you a few reasons to think about what is not simple, something that's clever, something that's unfamiliar doesn't mean it's actually simple, or just because it's familiar doesn't mean it's simple, not over-engineered, and a few other reasons. But I want to still talk about maybe what is really simple. Well, the first thing I want to talk about is simple keeps you focused. Now, one of the things that is the most precious in this world is to keep people's attention, and our own in today's world. We live in a world of Twitter, tweets, and Facebooks, and every possible distraction that's going to keep away from what we do. And attention is the most difficult thing. So one of the things I try to really do is to remove things around me that distract me. As much as possible, I want to avoid distractions. Well, imagine you and I are sitting around and working together, and I'm not really sure what real API function call I should make and what the parameters are. As we are scratching our head, you might suggest to me and say, why don't you search for it? Why don't we just look it up? I'm like, okay, so let's search for it and look it up and find the details about this particular API's documentation. Where am I going to go? Well, maybe I'll go look for it in Yahoo. The minute I go to Yahoo, what do I see? Here's the search, but wait a minute. There are some really interesting topics over here. And I'm going to kind of skip through these. And there's something about Colorado which always attracts my attention because I'm from there. I want to know what they are saying. Oh, that's awesome. We really make good use of sunlight. Do you know Colorado has 300 days of sunshine? This is amazing actually there. Notice what I just did. I got totally derailed in my conversation, and I'm talking about stuff that's absolutely unrelated. Well, that's exactly what happened when you go to the Yahoo Search. I was mentioning this in one of my times of presenting this, and somebody came to me after the talk and they said, but you know what? Somebody worked for Google, went to work for Yahoo, and they had the same point as you did, so they implemented a search page for Yahoo, they said. I was like, that's really curious. I want to know what it is. And I said, show it to me, and I think it was like search. And when you go to it, that's Yahoo search page, which is kind of awesome, isn't it? And so you can see that they also are adopting some of these ideas, but the last time I went there, they still had some ads in the bottom showing that it's really hard to let go of our ideas. I think some of these comes really down to the culture and how we perceive things. Rather than using Yahoo, of course, I could go to Bing. Well, a little bit better, but the minute I go there, I'm like, what a cute picture that is. And I don't know what that picture is. And I'm kind of curious, maybe I'll Bing for it. But that may lead to a recursive search because another picture may show up, it's very scary. Or I could do something a little different. Quick question, how many of you use Google? And there's a reason why you all raise your hand, right? Because you want to stay focused. Because when you go there, what does Google say? Why are you here? Well, if you want to know about something, search for it. If you're not going to search for it, I'm not going to distract you. Make no mistake, right behind those buttons is a complex set of architecture and design and software systems and hardware supporting that query. When you're not clicking on that button, servers are collecting data continuously. By no stretch of imagination am I saying what is there is simple. But that simplicity has not been put on our face. As a user, you don't have to endure any complexity at all. And make no mistake, do you think the first day at work when this was built was an easy day? Can you imagine the room when the engineer walks up to the boss and says, I've designed the search page. And the boss says, show it to me. And he says, here you go. And the boss says, what the heck is that? That's a search page with a text box. And what else? That's it. Well, because I know you're going to ask me, I put a I'm feeling lucky. Well, you should, right? Well, the point is, do you think this was a simple idea to present? It's a simple solution, but how many of us would have the courage to come up with this? I don't remember now, but maybe 5-6 years ago, there was a day when you went to Google, suddenly there was a background picture on Google. And there was a hue and cry. Within a few hours, they took it down because they did make the mistake like everybody else does, because we all feel we got to put a clutter around things. We can't just keep things simple. That's our human nature. It's incredibly difficult for us to do that. Well, so as a result, we make things really complex. Here's another quote I really like a lot. Perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. So it is really, this is exactly what I do when I refactor. I remove and remove and remove things away until there is nothing more to remove. And we can make things better by removing all the clutter, all the unnecessary details, all the things that really complicate. So it is to me, if you ask me what do I do for a living these days, I go to organizations to help them remove code. And when I leave, they have a lot less code than they did when I walked in. And that is one of the things I really try to take the time to do, is to remove the complexity, all the unnecessary clutter that we tend to have. So simplicity eliminates accidental complexity and hides the inherent complexity. We cannot remove the inherent complexity from applications, but at least the accidental complexities, we should strive to remove those as much as we can. The next thing about simplicity is, I mentioned that we can make things simple by avoiding unnecessary details to keep focus, but simple also fails less. Here is an example. Here is a little manhole cover, and I can ask you the question, why is the manhole cover round? And I'm sure most of you probably will snap back with an answer, saying that, oh, it's round because it won't fall in. And that's a valid answer. But if I gave you a spec, we are all developers, isn't it? You're sitting at work and are given a spec. And the spec says, design something that doesn't fall into the hole. I can bet you we would come up with the circle. We would come up with all these shapes because none of this fall into the hole also. And guess what? Every one of these will get you more money than the circle. Because you look at this and say, isn't that cool? Or is it more solving the problem? Well, circle is simpler than any of these solutions for yet another reason. And that reason is, sure enough, it doesn't fall in, but at the end of a very long day, when somebody comes out of that hole, the last thing the person wants to know is, how do I fit this in? And this is a very simple answer. Roll the damn thing over it and go home. And that's another reason why this is a good idea. Not just it doesn't fall in, but you can put it in any direction you want to and it fits. That's really incredibly good as well. So simple things fail a lot less and intuitive and easy to work with. And it's easy to understand, easy to work with, and that's what we should strive for when creating simple things. For example, I wanted to find out if a number is prime, but I want to get a collection of prime numbers. Well, here's a little example. E is prime. That tells you whether a number is prime or not. Doesn't matter. It actually does move on. But here's the primes function. This primes function says, starting with a given number, if the number is prime, I'll concatenate with the remainder of primes. Otherwise, I'll skip it and give you the remainder of primes. This doesn't work. The reason this doesn't work, of course, is because it'll get into an infinite stack overflow. Well, what do we do about this? Here's another idea. We could use an infinite stream. Well, if you notice streams.iterate, it is an infinite stream. It does lazy evaluations, which is a really good thing. And so I'm able to write expressive code where I can say prime 0, 5 or 100, 7. And because it's a lazy evaluation, I can ask it to evaluate just enough. I have to say that I'm really excited about infinite streams available in Java. And that's because there are a slew of problems we never really cared to solve elegantly that is now possible with infinite streams. But just to share with you one experience I had with this, I'll come back to this problem in a minute and show you how I used infinite stream to solve this. Well, simple is also elegant. And elegance is not easy. Aesthetics is not easy. And sometimes it's really hard to arrive at in the first sitting. And if you really look at it, we all say this is one of the best work any human has created. But why is this really a masterpiece? And I'm going to argue it's because it doesn't have any clutter. It is elegant not because of what is on it. It's elegant because of what's not on it. What is it? It's a picture of a lady. That's it. There is no clutter. There is no ornaments. There is nothing to distract you. and it really brings the natural beauty out. And that is why we appreciate this as one of the best pieces of work humans have created. And that is elegance, and elegance really doesn't need clutter and complexity around it. I want to really bring this to something a little bit more concrete, if you will. And I'm going to talk about an architect's dilemma. One of the things that drew my attention was this church when I went to Boston. I was with my family, and I was looking at a church, and this is the Trinity Church in downtown Boston. As you take a walk around Boston, you see this church, and I was staring at the church. I was staring at it for so long until my wife said, if you don't move, I'm going to call the cops. Why was I staring at this for so long? Well, actually, to be honest, I was not staring at this church. What I was really staring at was the reflection of the church. And next to the church, there is a building, and this is the Jan Hancock building. And when you look at this building, when they were about to construct this particular tower, they couldn't get permit from the city. The city said, no, we're not going to let you construct a building here, because when you do, the beauty of the church will go down. And the architect involved on this project said, no, I'm going to build the church here, and when I'm done building it, the church is going to look more beautiful than it does right now. And so he angled this particular tower in a particular position where it had a phenomenal reflection. I do have to say my camera didn't do a good job, actually, but I was mesmerized by this. I was staring at the tower's reflection of the church for so long. It was just amazingly beautiful. And that really comes back to our solutions. We can be really creative in coming with solutions, and sometimes the best solutions we can come up with is the simplest one. Well, but simplicity has to evolve. It is not something that will strike you on day one. As an example, well, Richard Feynman said, if you cannot explain to a first-year student or a 6-year-old, then you simply haven't understood it. And this has been my experience teaching for the past about 30 years. When I go to classes, I remember one fine day I went to class and I started teaching something. And I had the really hard time explaining this. I struggled for an hour. And I told my students, you know what, never mind. I'll get back to this tomorrow and I will teach it again. And I went home that night and spent several hours on this. And the next day I went and I explained it. And they got it right away. And they came to me and said, oh my gosh, you struggled with this yesterday for an hour trying to teach us. You got this so quickly. What's the difference? I said, the difference is very simple. I did not understand this topic yesterday when I was trying to teach it to you. And that is the whole point, is if you haven't understood it really well, it's extremely difficult to teach that stuff and help others understand it. But when you understand something really well, you will find a way to even make a child understand what you're trying to say. And that's exactly the point Feynman makes in this. And that is something to think about every time we deal with things. And Occam's razor says if you have two possible solutions to a problem, we have to choose the simplest of the two. I came across this when I was writing the book on Java 8, and mine was one of the very first books on Java 8. I was writing it in parallel with the release of Java 8 itself, and I released the book on the day Java 8 was released. And during this time, my question was, how could I introduce some ideas that are available in other languages into Java 8? Well, one of the things I wanted to do was to show an example of tail call optimization. I got a factorial right here, as you can see, but when I run this factorial on a very large number, I get a Stack Overflow error. I wanted to show tail call optimization. I've read the book like Structured and Interpretation of Computer Programs, and especially in this book, they talk about a difference between a process and a procedure. A procedure is a piece of code you write. A process is what actually runs that piece of code after transformation. You could write an iterative procedure. It could run as an iterative process. You could write a recursive procedure. It could run as a recursive process. But the real power comes in when you can write a recursive procedure, but it quietly runs as an iterative process. And there are some languages that do this fairly well. For example, Haskell and Erlang have tail call optimization built into them. Clojure does this on the JVM. Scala does this using compiler support also on the JVM. Groovy, on the other hand, doesn't do this using compiler support. It does it using library support. I've looked at these languages. I know how these things work. Java does not have tail call optimization, but I really wanted to show how to do tail call optimization in Java So I set out to write an example while I was writing the book. And as I was writing it, I came up with an example to table optimization. But the real code I want to spend time on is not here. But I spent 2 days working on this piece of code. At the end of 2 days, I spent yet another 10 hours on this code. And what I ended up with after all these, about 3 days of work, was this piece of code. And if you notice in here, I come in here with a method called invoke, and it goes through and says, while not call complete, current equals current.apply, and then repeats the call over here. When I finished it, I was in a lot of pain because I wasted 3 days of my life doing nothing. And then when I finished it, all I ended up was this suckish code. Because what's wrong with this code? I want you to look at this one line, current equals current.apply. What is that? That is mutability. I am changing current to the next value of the apply. Well, you see, until that page in the book, I think this was chapter 6, I think, until that page in the book, I kept reminding the reader, avoid mutability, avoid mutability, avoid mutability. And in this example, what was I doing? Use mutability. And I spent another half a day. And finally, I came with a solution I thought was brilliant. My solution was to write a paragraph in the book that said, dear reader, notice I'm using mutability on this line. Turning this code into immutable is left as an exercise to the reader. I thought that was a good solution, by the way. But we live in a world of Twitter. In books I read 20, 30 years ago, you could write a book and hide, and nobody would ever find who you are. Not today. The minute you publish this, people are going to tweet and ask you, how the heck do you solve it? And I said, that's not going to work. Then I spent another few hours, and I came with the next brilliant solution. I said, notice I'm using mutability. Don't use mutability except in places like this where you cannot avoid it. And I said, that doesn't go well either. And I said, okay, finally I figured out one thing. Very, very clear. And I realized that my code sucks. And I kind of left the problem away and said, maybe I won't even put this in the book, I'll go away. And I was there about 2 days later working on other things. And I was on a treadmill jogging when I suddenly realized, oh my gosh, I could turn this into an infinite stream problem. Just that thought in my mind, immediately the solution was clear in my mind, just never implemented at that point in my mind. So I jumped off the treadmill, ran across the floors of my house, went to my computer, and within 15 minutes I had the solution working. So all I had was, I said stream.iterate, start with the current tail call, apply, then only get the first one where it is complete, but get the first of that and get the result. Well, this technique works really well because of infinite stream problem. And all that I needed in my mind was to think about how to formulate a tail call optimization into an infinite stream problem. This is a solution that eventually landed in the book. And this was aha moment for me because it took me that long to figure out a solution that could avoid mutability and could be easy to work with. But I want to kind of go back to what Einstein said about this. Everything should be made simple, but as much as possible, but not any simpler. But I always doubt. When I create something, sometimes I feel that this is complex, and I would tell people to make it better, make it simpler. When I create something, when somebody else looks at it, they often tell me, oh, that could be simpler, that could be better. But how do you know whether something is simple or something is complex? So is the solution I create simple, or can it be simpler than what I created? And I feel that simplicity is a Schrodinger's cat. Maybe it is simple and complex at the same time. Maybe it is simple right now as we look at it, but maybe we can make it simpler as we work through it. It is not easy at all. I'm going to say making things simple is, simple makes things easy in the end, but making things simple in itself is certainly not very easy at all. It's a really, really hard work. And that hard work is extremely important for us to put in the time and effort to do. And the reason I would emphasize is because of Da Vinci's words. He says simplicity is the ultimate sophistication. So if you really want to make things better and improve it, we have to really ultimately make it simple in the end. But that's not an easy journey. But I think we get better at it the more we strive, the more we struggle, the more we try, the more we work. we become better at doing it. And so that is one of the reasons why I like to really work hard to make things simple. Like Einstein said, any intelligent fool can make things complex and violent, but really it takes a touch of genius and a lot of courage to move in the opposite direction, and that's a direction I want to move. Hope that was useful. Thank you.